Hello.
Hey, Sage.
How you doing?
Hello.
Oh. Great. Let's see. Here's the agenda. Let's see, we don't have Kifu or Sam yet. Radek, are you still in San Francisco or have you headed home already?
Yep, I'm in San Francisco. My flight got cancelled.
That's too bad.
Yeah, but I'm here.
Yeah. Do you happen to know where Kifu and Sam are? Did they head home today or?
Well, Sam is already in the air, I believe. Kifu he's in his room. I will ping him.
Okay.
Half an hour he got up just to be ready for the meeting, so he should be on.
Pinged, waiting for Pong.
All right. Hi, Kifu.
Hi guys, sorry for being late. I got a little bit tiring. Can you hear me?
Yep.
Okay.
All right. All right, so Sam's in the air, you said? He's flying home tonight?
Yep.
Okay. All right, well, let's go ahead and start with the Crimson update. Bratislav, Kifu, maybe you can just give a brief overview of what you guys covered. I don't know if you have any links that you can share as far as what the current status is.
I'm posting in the chat. Probably I can do a quick update using these slides. How about that?
I think you need to change access. Get access denied.
Yeah, I can share the screen.
Oh, perfect. Okay. Thanks.
Let me do it. Can you see my screen?
Yep.
Okay. So I think the Crimson started like 1.5 years ago, and I have a short introduction of Crimson, and we'll share with you guys the latest progress and a little bit our plan.
We just see your background right now.
Sorry about that. Probably I will just use this. How about now?
Now I see your blue screen or your whatever your share screen.
Let me try again. Can you see the slides?
I see your blue jean screen. This happened to Mike the other day. It was like, I think it was because he was using the app or the Chrome plugin or the other way around.
I'm using the app. Anyway,
Well, I think that Google Doc is open, so maybe we can just walk us through it.
yeah, probably I can just move on. If everyone also have access to the slides.
Yeah. Yep.
Okay.
That's not going to be very good for anyone watching the recording, though.
Okay, I'll try harder.
Here, I can share the slides.
Okay,
Do
thank
that.
you. Okay, that's the idea.
All right. All right.
So the agenda is to update you guys with the short introduction of Crimson and the data core and a little bit of the Crimson is basically a faster OD. The goal of it is to have less overhead, which was introduced by system core, memory copy, and context switches, because we have a bunch of threads which are basically competing with each other in existing OSD. And our goal is to target the mainstream modern storage device 2 years later, because presumably we will have a Crimson GA. If everything goes well, it will be available
A couple years.
2 years later. That's our plan. Next. So currently we have a following components like memory client, monitor client, and both Crimson and the existing class OSD share a bunch of facilities. We already have like encryptions and authorize, etc. And we will keep on using them. And for using C-star, we also come up with some. We also rewrite part of the shared infrastructure like memory client and monitor client, and also logging and configuration and messenger. Currently, the Crimson Messenger is almost feature complete, and it's able to talking to existing async manager and single manager, and it support B2 protocol. And before we protect the Crimson OSD, we think that we might want to have a single process and multiple reactor model. By reactor, I mean we will have a single process which is able to manage multiple cores. But currently, we have a single core and a single thread model. That's what we've been discussing, like M2N and 1-to-N. Currently, what we have is 1-to-1 mapping. That's greatly simplifies the model, because if we need to tackle the M2M problem, we will need to share the connections between different cores. So at this moment, we don't want to spend time working on this. So our decision is to postpone this problem to future, and that's not a serious problem at this moment. And next, I will try to explain the. Probably you can went back a little bit to the Crimson components. At the rightmost part is the object store. So currently we are prototyping using the memory store, which is move back to the 6th slides. So currently we are using a variant memory store, which is that simple, and the beauty of it is that we can change it and to use to use that as to shape the interface of a futurized object store, so we can have a better understanding of what the interface should look like. And in this aspect, it worked pretty good. And then we will try to port BlueStore to Crimson. The idea is that it could buy us some time before we have CStore. Probably you know that BlueStore took us like more than 2 years to stabilize it, and presumably CStore will take two.
Take time too. You still there? Did we lose them?
No, I can't hear him.
Yeah. Radek, do you want to talk through these till Kifu comes back?
Hello,
Or Neha?
can you hear me? Can you hear me?
Yep.
Okay, sorry, the network connection here is a bit unstable. So, those slides are conveying the performance, the comparison between classical OSD during some common operations. The absolutely key part, and the reason why this one comes as first, is that we are focused on the computational efficiency. The Crimson project isn't about developing an OSD that with a single instance will bring you more IOPS. It's more about developing a replacement for OSD that is much more computationally efficient. And by the computational efficiency, we use quite simple metric. It's the number of cycles per single operation. However, it can be derived from the IOPS and CPU util. And here we see that the number of cores the Crimson and Ceph OSD have taken during serving the same workload. Crimson is more efficient. The lower the better. Next slide, please. And well, this was I believe this was one client testing, and we can see that the number of IOPS is almost the same. I bet that we were bottlenecked by a single client. For Crimson, one client is not enough to saturate it.
Yeah.
Still, we are more computationally efficient.
Yeah. Latency too.
And average latency at the moment is the same. So, that was about testing with Memstore, and we really need to be aware that most of the performance problems are in object store. For instance, to give an argument for that is let me say about the testing Mark Nelson made some time ago. It was about comparing the the CPU cycles per op metric between classical OSD running the mem store versus classical OSD, not both classical, running BlueStore. And actually, for the first case, it's classical takes around 100 of cycles per 4K random read, but while going with BlueStore, it increases to more than 300,000 of CPU cycles. In summary, the object store part of the project will be more important even than the OSD layers that Crimson already has, that Crimson already implemented. And here is well, we have a bunch of possibilities how to crunch the object store matter. We could go with a completely new design. For our work, temporarily we call it sister, but it's not the sole possibility. There is some ideas about bringing store to the Crimson world, and this in turn can be it can be divided into yet another pair of possibilities. One is to sisterize BlueStore, which boils down basically to porting RocksDB to sister framework that Kifu already did with nice performance numbers. Another one is a possibility. Oh yeah, that's the figure. That's the numbers.
So this is DB-Bench is the RocksDB benchmark.
Exactly. If I recall correctly, during the sequential reads, yeah, during securities. The second possibility how to bring BlueStore to Crimson is to make some kind of adapter between C-Star and their futures and vanilla BlueStore. That's actually the part that Intel is working right now. We got initial pull request. I would say that Alien adapter is almost ready.
Okay.
But BlueStore, we are afraid that BlueStore. Well, we are afraid that alienized BlueStore isn't the long goal. It won't be affordable for the very fast devices we are targeting. It's just too costly in the matter of CPU cycles per op. So we started this week. We started designing. We started talking about new possibility, about C-Star, about new implementation of the object of the basically C-Star of the futurized object store interface that would address those very fast devices that will be written from ground up. But it's a longer story. It's just begun. So if there is a bunch of links, if somebody is interested, please follow.
I think we should say that we used this week the meeting here to decide to go over options and decide what options we want to try and create mockups first, research. and to divide some of the work to people. So we made specifically dedicated the meet this week to deciding how starting the actual work on Sisto.
Cool. Okay.
Well, we decided that refining the design actually requires a lot of experimenting, and we planned a couple of experiments.
Okay.
That's the main outcome from the Sister Summit.
Sounds good. Is any of that reflected on the task board, or is there like a document with notes from the meeting or anything?
There is a document. Need to find a link.
Okay. Awesome. Okay. Sounds great. How was the CSAR Summit Monday?
Really nice. 40 developers inside, and it was extremely technical, which is nice.
Nice. Did you presented your error exception?
Yes,
Errorizer.
Exactly. As a Red Hat, we made 2 talks. One about Kifos about Crimson, and mine about the errorator concept, which might be actually pretty generic for all sister-based projects.
Cool. Okay.
And by the way, for many issues that we asked Sister about, the answer, most of them requiring changes to GNU compilers, or other parts of the system, the answer we got was, you're a Red Hat. You should apply pressure inside Red Hat to get things done.
So, Sage, do you know some folks at GCC?
A few. I need to know what to tell them now. Yeah. Yeah, maybe a summary of what the most important items are would be helpful. I can figure out who to talk to. Absolutely.
Good. We should write down what we wanted and see if we can push it forward.
Yeah. I mean, is it stuff that's coming in like C++ 21 features, or is it like code generation stuff?
Low-level things, low-level, sometimes some low-level programmers, extensions, sometimes improvements in scalability and performance of already existing mechanisms.
Okay, sounds good. Okay, yeah, a summary would be good. Great. Okay. Any other questions on the Crimson stuff? I should mention.
I was in the summary, and the next step, what we are going to experiment to the Ceph devel, so we can have a more eyeball on it if anything is terribly wrong, and to get more inputs and more ideas probably.
That sounds great.
So we are still experimenting the ideas.
Okay. Okay. And most people already know this, but there's a weekly call on this every Wednesday. That is, I guess, 22 hours before right now. That's when it normally is. So anybody's welcome to join to get a status update. All right, Josh, do you want to talk about small objects?
Sure. So there's been a number of interesting things going on with small objects that recently, where we started noticing that they have more overhead in certain cases than we had seen before, and there may be some ways that we can avoid that. Mostly this is in terms of space utilization, and there are a couple things we can do, I think, at both the object store level and at the OSD level. So at the object store level, we've already been discussing with benchmarking from Igor and Mark towards reducing the minimum allocation size to 4K, so that objects 4K or smaller only take up 4K and not 16K on SSDs or 64K on hard disks. And from the testing so far, it looks like there's actually an improvement in performance, which is nice to see since it wasn't the case a few years ago. I think there's the remaining pieces there are some bits to fix up with the combination of the minimum alloc size reduction to 4K and the combination of allocators to a single allocator. There's still some interaction there that needs to be worked out to make sure that the performance doesn't get worse in that case. At the OSD layer, I guess there's one more proposal at the object store layer too, which is for very small objects, optionally storing them within RocksDB instead of on a Bluestar device, and so that they wouldn't even occupy the min alloc size at all, but be part of a much larger SS table structure, and presumably have much lower overhead there. So that would help with very tiny objects that are below 4K or whatever the min alloc size is. And there are two PRs for, with slightly different approaches there. One of which looks like it had a fair bit of CPU overhead, and the other one doesn't quite have enough benchmarking yet to tell. But since these are, I think both of them can be turned on or off depending on the circumstance, like either by the Libreo's client or by some heuristic we can put in the object store. The overhead can be made optional. At the OSD layer, another aspect to this is erasure coding. So today, if you write, say, a 4K object to an EC pool, you have to write the entire stripe width of that EC stripe. So by default, the way pools are created, each individual shard of an EC object will be will try to match the kind of Bluestar minimum of 4K. So if you write a 4K object, you'll end up with a 4K on the first shard and all the other shards with an empty object and an O node they're representing on each of those, which is fairly wasteful in terms of both the O node metadata and the extra empty object there and other shards. So it seems like you might be able to optimize this by just not writing those extra shards if possible, or having some kind of representation of an empty object on them that doesn't waste so much space.
I mean, they'll only consume space in RocksDB. They won't actually have any blocks allocated. So they should be, a couple hundred bytes.
We don't actually write the zeros? I thought we did.
No. Oh, I see. Right. Yeah. I see.
Because we've had this right back with zeros when we were writing to a partial stripe in EC.
Right.
So unless Bluestar is detecting them and limiting them, I think we're still writing them out.
Okay. Yeah. Okay. Yeah, like if we know it's a zero buffer, then we could just resize the object, but have a hole in the object allocation or whatever. That'd be nice.
I wonder if it's worth having some kind of hints at the librators level to specify that this object is immutable. So RGW could use that as well. And if we know that
we have such a hint.
Okay, we have that already.
Yeah.
The RGW uses that for compressing, right? That hint's basically saying it's an immutable object. Like it's not sequentially, it's like got random access and
there's
a few flags.
There's one. Yeah. There's one that says that read access is going to be sequential, which hints so that the checksum blocks are larger. Let's say have less checksum overhead. And there's another one that says that you don't expect to overwrite it. I think it's actually the combination of the two that makes us use a large checksum. I can't remember exactly what the flags are called, but I'm pretty sure those hints are there. But it seems like here we need something slightly different because we basically need the output of the erasure code when it's writing the erasure code block to notice or know that it's zeroed and then efficiently store the zeros, basically.
Yeah.
I mean, we were just talking about this with Igor. Actually, it could actually make sense to do just a really fast heuristic or whatever to do it, because if you look at the first word of the data and it's zeros, then you can do an expensive walk through the whole thing.
Mm-hmm.
But most of the time, if it's not zeros, the first word is not going to be zeros, and so it'll cost a couple cycles at most just to do that check. So having blue store itself at that layer just detect zeros and store them efficiently might be pretty reasonable.
Mm-hmm. Yeah, it certainly seems like a relatively simple way to get it, get the benefits.
It's worth. Yeah, I should look at that. I'll put that on my list.
Another possibility might be, which is probably might be more too complex, but trying to replicate those objects, those tiny objects, rather than storing them in EC at all.
Yeah. That actually, I guess that's the RGW approach, right? If RGW, when you write the object, I'm pretty sure they know the size that you're going to write, and so it could, if it has multiple Rados pools available, it could just, if it's below a threshold, it could just put it in there for a replicated pool instead of the erasure coded pool. Yeah.
I'm not sure how that works out with the user versioning stuff. I think that at least used to depend on some of the PG level versionings.
Question. I'm not sure. Yeah, we'd have to check, because the way that Rados Gateway works, actually, there's all of the head objects in the bucket are always in one pool, and then the rest of the first 512K or whatever is always in one pool. So it might just be that by default that pool is always replicated for the first little bit of the object, and then only everything over 512K or whatever size you choose gets erasure coded. In which case you sort of get this optimization for free.
Though it wouldn't apply to existing clusters so easily.
Yeah.
Well, maybe we could try prototyping the Blue Star approach and see if it had much overhead.
For the detecting zeros.
Detecting zeros.
Yeah. This came up in, I think it was actually BlueFS. Igor was looking at it. I think it's actually pretty to do, so I'll check with him.
Okay, cool.
Okay.
Yeah, I think that was all I had for that I was thinking about. Anybody else have any ideas about small objects?
I just wanted to continue on the same topic. So if we do that at the RGW level, we'd have to probably be restricted to a pool type, where if we decide that a pool is replicated, then we have to make it replicated in all cases. So if it is small objects, it's basically a small object pool of replicated type. So it's a restriction for the user. But if we do it under the hood on the OSD level, the OSD could have some kind of smartness to detect whether what kind of, it's a longer term solution. I'm not saying it's easy, but it's more like, okay, it's some kind of machine learning that that I'm only receiving small objects of this size. So why don't I just try to replicate it under the hood? And it would not be called an erasure coded pool. It would be called something like a hybrid pool. but that could give us the benefit, not just for RGW, but any kind of application that writes small language. But yeah, it's not easy, but that could be one way to deal with it.
Yeah. Yeah, it sounds harder to me. But yeah, like it's a Ceph case where you have small files where this would come up, I think. Because there you don't know whether this file is going to be big or small. Writing it. I mean, I think just doing the blue store part, it will mitigate some of it. Maybe even most of it, but and the RGW one is sort of easily solved at the RGW level, I think.
And if we can reduce the min-al access to 4K, that helps awesomely. So
that helps a lot. Yeah, I think that the thing to watch out for there is that that is going to make fragmentation worse. And so I think we probably want to think about ways to sort of defragment on the fly. And I think that the simple idea is basically when we do a deep scrub and we're reading every object, if we can make it notice that the object is reading is heavily fragmented, and if the load is low enough, then we'll just sort of rewrite it as we go.
With the goal of basically reducing metadata, like
yeah, and overall fragmentation, so your future read performance will be better when you go back and read it real as opposed to just for scrub.
Does that really matter for Flash, or is this you're also concerned about?
I think it does matter, because if you, I don't know, it's hard to tell. It's more complicated. I mean, the FTL is packing together all these different write streams, and the garbage collection that the SSD has to do is when you have like data that's sitting around for a long time next to data that's been deleted. I guess it probably matters less for Flash.
Yeah, I thought it was moving data around under the hood anyway with its own abstraction layer.
Yeah, I think it matters more for writes. Like the sequential write performance is much better than random writes, but for reads, random reads are still very fast, right?
Yeah. So we could do it over hard drives and maybe not for Flash then. Rewriting will improve the metadata, I guess. Yeah, I don't know. Let's see.
Oh, the one other thing I wanted to bring up, I guess, was possibly looking at reducing the metadata we need per object. I'm not sure if we've looked at trying to optimize the node size recently. But for these tiny objects, it can be pretty significant.
Yeah, I mean, we spent a lot of time on this like a couple years ago when we were developing BlueStore. With the way that we encode, we do like differential values and varant encoding and so on. I think the most expensive part is usually the checksums. That's what will take for a 4 meg object with 4K granularity checksums, it's 4K of checksum data. That's the main thing that blows it up. That goes way down for RGW because you're writing things sequentially, you're not doing overwrites, so they don't get all fragmented, and you also have larger checksum blocks. RGW, the metadata is pretty efficient. It's really just RBD objects that have like random write workloads. Those are the ones where the metadata gets super gross.
I guess I'm more thinking of the tiny RGW objects where at that point the metadata is almost the same size as your objects. So
yeah,
you're sacrificing a lot of your storage for that.
Yeah. I mean, I guess it depends on how tiny. Like if it's a 4K object, the metadata is going to be much smaller. Like it's going to be a few hundred bytes. Maybe half.
I think with the space amplification from RocksDB, we're seeing more like a few K.
Really? Okay.
The 10K.
Yeah. Yeah, I think that's an argument to put it in a replicated pool because you don't have that O node. You don't have K plus M O nodes. You have three O nodes or whatever.
Or if you can avoid keeping O nodes for non-existent shards. Oh.
Yeah, that I think would be pretty tricky, but it might be possible. I think it'd be pretty hard. We wouldn't know, but yeah, I don't know. I guess it's worth checking. Yeah, that would be worth looking into because that would help. Okay. Any other thoughts there? All right. The next topic was a CephFS item on the ephemeral pinning. Patrick was going to give an update, but I don't see him here, so I think we'll skip that. Actually, that wasn't the next topic. The next one was dedupe, but I think we'll end up skipping Patrick too.
Can you guys hear me?
Yep.
Yeah, I'll be speaking. I can speak about
okay.
ephemeral pinning.
Oh, cool. Okay.
Yeah.
Great.
Yeah. I'll share my screen.
Perfect.
Can you see my screen?
Yep.
Okay, cool. Okay, so I'll be giving you guys an introduction to ephemeral pinning and then proceed to give a brief walkthrough of the code. And finally, how we plan to benchmark the metadata distribution and the load distribution.
Okay.
Now, I'll start with some background on why this feature request even came through. I guess the main reason would be the metadata balancer and the not so optimal distribution that it gives in a lot of the cases. And plus, you could see stuff like excessive migrations, back and forth migrations, and we obviously don't want that. Now, export pinning or subtree pinning is an efficient strategy in CephFS to partition the metadata across MDSs and even without the balancer interfering as well. Also, you could get a fairly linear metadata throughput scaling with increasing number of MDSs. But then again, the problem with subtree pinning is that you're dependent on the user or the admin to specify the subtree partitioning. That is, subtrees are handled by which MDSs. Now, this gives a need to dynamically pin the subtrees using some kind of partitioning strategy. And so we've come up with export ephemeral pinning. Now, export ephemeral random and export ephemeral distributed are the two config options to be used for ephemeral pinning. Basically, both of them are two different ways of partitioning metadata, or basically two different partitioning strategies. Now, this is all facilitated by using consistent hashing. I'll explain how we use consistent hashing in the subsequent slides, and you'll also see the data structures, which is in the MDS map when I go through the code. So in export ephemeral random, the partitioning strategy is almost similar to that of a naive subtree pin, in the sense that it's hierarchical and the whole subtree gets exported. The difference here is that as the directory fragment gets loaded, its inode gets a pin based on a probability, and so it doesn't happen 100% of the time. So this config option, that's export ephemeral random, is a float value from 0 to 1. And if it's 0, then the spinning is disabled. And the other values specify the probability of the pinning. And also the target MDS to which the subtree should be pinned is found out by a consistent hash of the inode number. Now, the next config option is export ephemeral distributed. In this case, only unlike the export ephemeral random where you had the whole subtree, here you had only the direct descendants, which are the child directories, and only these are hashed and pinned. In this case, it's not probabilistic. it happens 100% of the time if it is not exported as export ephemeral random. Now, our aim is to have a combination of a pure hashing based distribution strategy and a subtree partitioning strategy. And using these two config options, we think we could get a mix of both of those. So I'll talk about the consistent hashing that's been used here. If people watching are not familiar with consistent hashing, it's basically a type of distributed hash table where you don't have to, where during cluster resizes, you don't have to rehash the entire hash table. You just have to rehash whatever metadata was mapped to the node that just went down. So it's basically like in a naive hashing scenario, you had order of n, and in a naive hashing scenario, you had order of k, where k is the total number of keys, and in a consistent hashing scenario, you have order of k by n, where again k is the total number of keys and n is the number of nodes. So how we've implemented it in Cephfs is you have a data structure called Mds Rank Node, which is basically the rank, which basically has members, the rank, the hash of that rank, and the inode numbers that it's responsible for. So this data structure is the primary node in the consistent hash ring. So as you can see here, the circles in the ring represent inodes. And rank 3 is responsible for those 3 inodes, and rank 1 is also responsible for the inodes before it. So the other ranks are also responsible for inodes, but I haven't represented it there because the operations that I'm going to do are going to be only going to happen in rank 3 and rank 1. So just note that inodes are also there for rank 0 and rank 2. So the first case would be when a new node comes up in the cluster, and this happens when you increase the max MDS. So say in that case, a new rank would be rank 4. So you can see that rank 4 comes up, and it takes up some of the inodes of rank 1. You can see that rank 1 had inode numbers 132, 112, and 156, and now rank 4 takes up 112 and 156, and rank 1 takes up 132. So this can happen by a simple check on rank 1 side. So you just had a binary search to figure out which is the inodes that's responsible for rank 4. So that's not computationally complex. The next case would be a rank going out of the cluster. In this case, it's simple. So here, rank 3 went out of the cluster. So you just had to remap all of those inodes to rank 1, because the successor node would be rank 1 in the ring. So you can see that rank 1 now holds all of those inodes. So for now we've basically implemented a pretty simple consistent hashing strategy. I think as it becomes stable, we'll also go on to try fairly advanced strategies where you had virtual nodes instead of a single node in the ring. So now I'll just go through the code. Okay, so this is the PR. So now I've only implemented the export ephemeral random pin. Export ephemeral distributed is a bit more complicated because it's not hierarchical, and usually exports happen hierarchically. The whole subtree gets exported, so that requires a little bit more work. So let's look at the data structures in the MDS map. So can you guys all hear me?
Yep.
Okay, good. So yeah, as you can see, this is the MDS rank node, and the It's basically a structure with the rank, the hash of that rank, and a vector of inode numbers. And then you have a vector of MDS rank nodes, which is basically a representative for the consistent hash ring. And you have a bunch of helper functions to add a node to the consistent hash ring, get the rank node from the inode, or put inode in the consistent hash ring, and so on. So yeah, that's basically it for the. Yeah. Go on.
The inode list there, those are the inodes where you have installed you set the attribute that says I want to do hashing on this directory. It's like a directory inode for /home or something. Is that right?
Yes.
So it's going to be a relatively short
exactly.
list of inodes. Okay, because this is going in the MDS map.
Yes.
We can't be a long list.
Yeah.
Got it. Okay.
Yeah.
But that's just going to determine the master MDS for that directory. The idea is that all the children get fanned out beneath that point.
I think for this case, for the random pinning case, it's fine because it's the subtree root, right? Even are you asking if the children also get the same pin?
Yeah, I mean, are the children going to show up in this list, or is it just the parent above?
It's just the parent. It's just the subtree root.
Okay.
Yeah.
Okay.
Yeah. So so these are the helper functions. I'm not going to go through it because this will take a lot of time, but you guys can check it out if you want in the PR. I'll link the PR. I basically commented out everything, so it's pretty easy to check it out. The computations are not that complex as well. I guess at most it will be linear. So let's look at where the export actually happens, the function where the export actually happens. So this is where it happens, maybe export ephemeral pin. So initially there's a few checks to see if it's already been pinned, and even if it's already pinned, there may be cases where during cluster cases where cluster resizes happen. In that case, you'll have to update the existing pin. So these are those checks. So the first one is where the rank where it has got pinned has now stopped. So that means max MDS just went down. So you'll have to update, and you'll basically have to get the successor of that rank node in the consistent hash ring and migrate it to that. That is why the get successor is called, and you're getting the target rank from that. And the next case would be where a new rank is added to the cluster. That means max MDS just went up. So this is called, in this case, it's called differently. So here it's called when the new rank is loaded, and it's called when the MD cache is initialized. And so I'll show you how that is called.
Could you put the pull request? Oh, there it is, 30592. All right, thanks. Put that in the chat.
Yeah. Okay. Yeah. So when max MDS goes up, this the pinning is usually called when so you can see in the MD cache this is under handle MDS map. So the MDS map changes, right? So you can see that the max MDS is different from the max MDS of the old map. So in that case, you start iterating the inodes and you start pinning it. So you can see that you get the inodes from the rank in consistent hash ring, and then you iterate over those inodes and you repin those inodes. So that's why you're calling maybe export ephemeral pin with an update value of true. So this basically means that you have an increase in the max MDS.
Okay.
So so this is that case here.
I wonder, do you know how this compares to the previous subtree pinning? Because I thought those were stored as attributes on the inode, and whenever that inode was loaded into the cache, that's when that's when the pinning was triggered.
Yeah, so in that case, you did. We'll have to do the same. I mean, we're also journaling it to the inode as exata, because we'll have to do that because there are cases where the rank goes down, and then standby MDS comes up and takes the role of that rank. So in that case, it's useful to have an exatter when it gets loaded. Otherwise, you'll have to. You could do it, but every time the cache is reloaded again to that standby that just became active, you'll have to do. The computation is a bit higher. You'll have to. I think it's order of n plus order of log k. So it's so instead of doing those checks every time it's loaded, it's better that you have an exatter, and you can just in constant time you can just know whether it's pinned or not.
Yeah. Okay.
Yeah. So here also we do journal it to Rados once we've decided to pin it. So yeah, so these are the cases where update happens, and yeah, so when it's not an update, and when you actually have to pin it, when it's a fresh pin, how a fresh pin is determined is basically you get the config value, which is basically the probability, and you check whether it's greater than or equal to some random number between 0 and 1. So this will fairly give you a random chance, not a random chance, a chance that's biased towards the probability, and to be whether it should be pinned or not. So yeah, so if that is the case, then you put the inode number in the consistent hash ring, and conveniently this function will also give you the rank of the rank that is going to handle this inode. So this is the target rank. Note this is the case where you have a fresh pin and not an update. So yeah, and then you go on to journal that. As I said, you go on to journal that to the as an exatter. And finally, you start the subtree export. This is similar to the subtree pinning case because it's hierarchical and you can export the whole subtree. So you basically put it in the export pin queue and wait for the balancer to migrate it. So that's basically how it happens.
I think we'll need to look at the pull request in a bit more detail. I don't know if we're gonna.
Okay.
Digest it right now. Yeah.
There's
okay.
Yeah, and there's also changes in the balancer, slight changes in the balancer, to make sure that the ephemeral pin does not override the subtree pin, and yeah, a few more changes for journaling as well, I guess. Yeah.
Cool.
So,
okay.
Yeah. So that's a brief overview of the PR I've done. Now. We haven't benchmarked it yet, but we plan on using these strategies for benchmarking it. So I guess the first one would be to yeah. So the first one would be to graph the number of authoritative subtrees per MDS. If we could do that for just for comparison between the ephemeral one and the naive subtree pinning or the balancer or the pure balancer one, it would be nice. And another metric would be the hotness factor of each MDS, and by a hotness factor I mean the number of incoming requests to an MDS in a certain window of time. So if we could get that, then that would be nice. And ideally, this should be almost the same in all of the MDSs, and there should be no peaks or spikes in the graph. Another useful metric, I believe, would be if we could measure the number of inter-MDS hops.
Yeah.
So inter-MDS hops is basically like the outgoing request from an MDS to another MDS is part of a lookup call. So I guess again, ideally, along with having a balanced distribution of metadata, it's quite important to keep the inter-MDS hops as low as possible. So yeah, that's it. And yeah, I've just linked the PR here. And I guess this is kind of a short-term solution. The ideal and long-term solution would be to make the balancer way more smarter than it already is, I guess, more adaptive to the workload, some kind of learning strategy, but that's not really easy.
Yeah, it's hard.
Yeah.
Yeah. I think for this benchmarking, probably one of the other key challenges is just figuring out what workloads to use to generate in order to test this against.
So I think Patrick and Ben has written a small file script, a small file workload. So that we'll be testing it with that. And then another would be probably building the kernel.
Yeah, or doing it like, you know, from 30 clients or something like that. So you get this.
Yeah.
Yeah, you definitely want, having one client building the kernel will be one thing, because you basically want that to do almost no rebalancing, because you really only have one request stream. Yeah. There's nothing to parallelize. But in the case of, it's when you have lots of them in parallel, you want to figure out how to basically get the clients on different MDS servers. That's really the challenge. It's almost not balancing the metadata, it's balancing the metadata that clients will touch so that the client work request streams get balanced. I think sort of the main thing that the current balancer doesn't understand how to figure out. Yeah. Cool. Okay. Great. Any questions on that? All right, I can do a brief update on the distributed dedupe. This came up a couple times this past couple of weeks in conversation, and I think a lot of people aren't aware of where the current status is. So I went and found a random pad, and it turns out that the last time we did an update was about 2 years ago. So that in the chat. So this is dedupe that's across the entire Rados pool, so dedupe across nodes. You can layer something like VDO underneath the OSDs, then it'll dedupe on a single host, but that doesn't really help when you have a many node cluster and you're storing data twice. You want it to actually, you still want to have one copy of that data. So what's done is a bunch of stuff. A lot of it is really infrastructure for like a sort of a simpler tiering model than the cache tiering. And this might be something that we can transition the cache tiering to and then be able to deprecate the cache tiering. So the idea in the dedupe case is that, well, the Rados primitive is that you can have objects that act like symlinks. So they have a manifest in the object info that tells you that the data is actually somewhere else. And there are two types. There's a redirect that says this entire object is actually stored in a different pool in a different object. That's just basically exactly like a symlink. And then there's, and the way that this is processed is the OSD acts as a proxy. So if you read from OSD2 for an object, it has a redirect, then OSD2 will go read the data for you from somewhere else and then send it back. So the client doesn't have to be aware of what's going on at all. And then there's also a chunked type, which basically says, in the manifest, it says, bytes 0 to 1000 are in this object, and bytes 1001 to 67K are in this other object over here, and then the whatever. So you can segment out where the data is. So that's all there. And then there's also a ref counting system for the actual chunks. So the idea is basically that you'd use one Rados pool for sort of for newly written data, and also as a metadata layer for where the dedupe chunks are. Because when you're doing dedupe, the fundamental problem is that Rados chooses where to store the data based on the name of the object, but we actually want to dedupe based on the content of the object, not the name. And so you need a metadata layer that translates the name to the hash value essentially, and then a second tier that actually has the content addressable chunks. So that's the idea, is that the base tier would be that metadata layer with manifest objects. And you back it by flash or whatever, so it'd be nice and fast. And then you'd have another tier that's all the dedupe chunks. So the chunks can do ref counts. The ref counts have sort of lossy back pointers. So if you have a small number of references, it actually tells you what object is pointing to you. If you have a very large number of references, then it sort of tells you you have 7 references from this pool and 3 from that pool, or whatever it is. So it's sort of a bounded set of back pointers. And then all the ref counting updates are such that if you there's no atomic update of the pointer and the ref count change, and so they're all ordered so that if you have a failure in between, then you just leak data, but you never have a bad pointer. And the back pointer metadata is there, so you could do a scrub in theory. Although I think in practice, you probably leak so little data that you might not even bother ever wanting to do that. So that's all done. There's a pull request that's in flight that's improving the ref counting so that it behaves properly with snapshots, because you have to basically decrement the ref counts on all your chunks, not when you delete the object, but when you delete the last snapshot that references those chunks. And so that's a sort of a rejiggering of the ordering of stuff and wiring it into trim object. So there's a pull request for that that's basically just waiting on review. I haven't had time to look at it yet, but I think once that's there, then most of the Rados fundamentals are in place. And then the other sort of missing, the thing that's mostly done right now, there's a Ceph dedupe tool that just has a bunch of arguments to call into some of these low-level bits and pieces in Rados to test this stuff. But it also has a function that will basically look at an existing Rados pool that's full of data and just sample a bunch of objects, and you give it what chunking chunk size you want to target, and it'll do the content addressable chunking stuff, and then do sort of an in-memory map that just will estimate what dedupe ratio you would expect with that particular chunking size. So you can point this at your like Rados gateway data pool and find out that you're going to get 2% reduction in size or like 80%, depending on whether it's video content versus web assets or whatever it is. I don't know. So the idea with this is that we want to be able to have actual users on real clusters run this on their data set and find out how well it's going to work, and find out if there's like a dedupe ratio that would work well for them. Because there's this basic trade-off between if you have very small chunks, if you do the content addressable chunking of the object, so you're breaking it into pieces. If you break it into small chunks, then your dedupe hit rates are going to be very high. You're going to be able to dedupe really well, but you're storing all these like really small objects, so you're going to have really high overheads. And if you do a sequential read on your 4 meg object that's broken into 1,000 little tiny pieces, your reads are going to be like unbearably slow. So what we really want is to have nice large chunks, maybe hundreds of kilobytes, but still get good dedupe ratios. And sort of the open question is like, with real data, can you have large chunks and still get good dedupe ratios? And I think that's really what's going to determine whether this is going to work for users in the real world or not. So I think like 90% of the work is done. What really needs to happen is somebody needs to like go look at this tool, make sure it works, and it's like easy to use and it's well documented, and then like write a blog post that says this is how you run this on a real cluster to find out how well it works, and try to get solicit some user feedback. Yeah, any questions? Any questions on any of that? Anybody dying to go look at this? I think that the main things that we're missing really is help reviewing the young ones' pull requests. Because so far it's just me reviewing it, and then figuring out how well it's actually going to work on real data sets. And then assuming that things look good based on those results, if that actually makes sense, then we can sort of do the final push to like finish this set of capabilities by expanding the test suite and documenting everything and re-reviewing all the code and so on. Yeah, that's the overall status. I Any questions, comments?
The last line there about a complete unaddressable storage Rados pool interface, what does that mean?
It's modular in the sense that there are basically two parts. There's the stuff that expands the capabilities of the index layer. So it's like the manifests, so that Rados objects can have these pointers to other objects, and they'll proxy the reads and piece them back together and so on. And when you delete them, the reference counts will get decremented. That's sort of the client side of the picture. And then there's the content addressable pool side, where you're basically just storing blobs of data. You're storing these objects and you're reference counting them. And the whole picture here is designed so that you can have a drop-in replacement for Rados. So anything that uses Rados, you could just turn this on basically, and it would do all the dedupe behind the scenes. But you could do that if you already have a metadata layer. For example, if you're Rados Gateway, then you could directly consume the content addressable. Like RGW objects have a manifest of their own already. And so when they write their big old chunks, they could just write them into the content addressable pool directly and bump the reference count, and then have their own pointers in their own manifest, and you sort of skip this indirection layer. So I think basically having that, how to use that properly in that set of interfaces, like well documented and sort of well tested, would be valuable for benefit of things like Rados Gateway, and also just to sort of separate the two concerns so that you don't have this pile of mishmash of stuff in Rados that you're trying to test and validate all at once.
Okay, that makes sense. And is the idea to kind of make sure that dedupe happen offline with the external tool first, and then eventually possibly put it into the OSD, or try to scale out the tool out in some other way?
As far as, right now it's an external tool, assuming that an external tool would do it. So that's actually mainly what this Ceph dedupe tool has in it right now. It's a set of commands where you basically say, take this object and tell Rados that it's actually chunks. It's composed of these other chunks. I guess probably the last step is going to be changing the sort of current agent, tiering agent, cache agent, I forget what we called it, that's in the OSD that in the background goes and scans objects that do the cache tiering stuff. Change that so that it does dedupe work, I guess. So it could look at objects that have been there for a couple days or whatever, and then read them, chunk them, and then rewrite them in a chunked form to make this sort of automatic whatever. But for now, I think just getting the I/O paths working properly would be the first part of it.
Yeah, that makes sense. Yeah, if it does work and reasonably well, it seems like we need that scalability to be able to address a large cluster.
Yeah. Yeah, I mean, one of the things I like about this overall architecture is that it sort of degrades into just like normal Rados. So if you just like don't do the dedupe agent in the background, then it's just a Rados pool, right? You're just writing into Rados, and it's in that sort of initial base tier. And so sort of at your leisure, at your option, if you want, you can go through and identify the cold objects and dedupe them, or you can not, right? And if the dedupe is slow, then like all your hot objects are like not deduped, and so they're all right there, and so they're going to be nice and fast, and so on. So it degrades gracefully. Whereas with cache tiering, you sort of like are building in this overhead and complexity by having the cache in place where you have to promote stuff, and I don't know.
Yeah.
It was a little bit weird.
I also like the idea of the like Rados Gateway writing directly to the essentially doing the dedupe inline.
Yeah, that would be basically free. Like it would take almost no CPU for the RGW to just do the chunking, and it could just do this all the time. You just have like free dedupe. Be nice. probably the hard part of the problem would be like knowing how much you're deduping and having like a doing the accounting. You know what space you're saving. But yeah. Anyway. Okay. Anything else on that?
I think I like the way you've created this document about what exactly needs to be done next. Should we make it a priority for Pacific, because I don't think we have enough time for Octopus.
Oh yeah, definitely not. Yeah, this is not. Yeah, definitely
Yeah.
not for Octopus. It would, if we can. That sounds great. I think it just depends on what else is on our plate. This has always been sort of a priority 2 item, which is why it's been 2 years since the previous update in this document.
Yeah, but mine might just be. Is there already a Trello or board or a card for it?
I think there's a card probably buried under. There are probably several cards actually in Rados.
Might just be worth like creating just one and linking this Etherpad there, and when we come to a point when we are planning stuff for Pacific, we can prioritize.
Yep. All right, here's the card, and I'll link this document in the card. Yep. Okay. I think probably if we sort of invest more heavily in this, the real win would be if we can figure out the work items that are necessary to make this work, and at the same time look at the cache tiering and have a path that converges the two so that we can deprecate the cache tiering. Not deprecate it, but actually like remove the cache tiering. If we can make it so that the OSD will sort of transition a cache tier and a base tier, where it just sort of populates the cache tier with all of these redirects pointing to the base tier, and then in a release or whatever, then in 2 cycles we can actually just remove all the cache tiering code, which would be some nice code simplification. Yeah, but we'll see.
Yeah.
All right. Okay, the last thing on here is telemetry and crash reports. I think this is, Brad, you had some questions about this. Actually, I don't remember exactly what we wanted to talk about here.
And I'm here if you need me.
And Dan's here, yes. Yeah. You're muted, Brad.
Can you hear me now?
Yes.
It auto mutes somehow. Great, very helpful.
Yep.
I am wondering if we could just have an overview of current status and a bit of a walkthrough, if possible, just a high level thing, and
Sure.
also interested in what needs to be done, what's left to do. I'm interested from an upstream viewpoint, but also from a Red Hat viewpoint as well. So, but maybe they're
right.
2 different discussions.
I can do a quick walkthrough of what works today. Here, I can share my screen. You see that? So this is this is a lab cluster. It's running Nautilus. There's a set of new commands of crash. Actually, let's start at the beginning. So for forever, we've had a SIG-abort handler for seg faults, that signal handle that triggers and dumps a bunch of crap to the log files, including a stack trace. And that's, up until recently, that's been like sort of the only way that you know what happened when it even crashed. But it required actually like noticing that there's this splat in your log and then going and looking at it and copying it somewhere. And so starting in Nautilus, and I think we backported it to Mimic, I can't quite remember. There is a new directory called varlib ceph crash. And whenever there's a crash, it also creates an entry in here and fills it with metadata. And then there's a Ceph crash utility that's running on every host now that basically every 10 minutes just looks in here for new crash reports and then sends them back up to the manager. The crash reports look like this. So they have a timestamp and then a UID. So they have a unique identifier. It's a directory. So each one of these has a few things in it. It's got, it dumps out that log, basically the same thing that it dumps as a regular log. It dumps here just for convenience, I guess. They have a recent history of the log, the same splat you've seen before. And then it has this metadata, which is just a bunch of JSON. So it's the crash ID, the timestamp, which process, which entity, what version, some random stuff about the OS. And then the main thing is it has a backtrace. So it's basically a JSONized form of the same thing that's in the log. So all of that gets posted to the manager, stores it in the Mon database. And so if you do Ceph crash ls, you see, all these crashes. You look at one of these, you do Ceph crash info. It'll basically tell you that metadata. Oops. It'll give you that same metadata. There's a new set of health warnings. So I don't know if it's in this. It's not in Nautilus yet. It's in master. It should be in the next point release of Nautilus, where there's additionally, when you do the Ceph crash ls, it's a little bit nicer. It's got a table where it says ID up here and then what entity, and then it says whether it was archived or not. And so your new crashes will appear as new, and then there's a new command Ceph crash archive ID, which will just basically set a flag on it and say that you've seen it. You don't need to look at it anymore. And there's like an archive all. There's an auto archive and some other random stuff. But the main purpose of that is that if there are new crashes, then a health alert is raised. So when you do Ceph health, whatever it'll say, there are 3 new crashes in your cluster. And then you can do Ceph crash ls. I think by default, crash ls only shows the new ones instead of all of them, something like that. And then you can look at them. And then when you say you acknowledge it and you want the warning to go away, then you do Ceph crash archive. You archive those crashes and then the health warning disappears. So that, I think, is basically the entirety of the in-cluster experience. The second half of it is that the Ceph telemetry will now include these. So if you look at all the telemetry that gets phoned home, stuff like, it's a bunch of stuff down here, like, what kernels you're running and how big your cluster is and so on. But it also includes all the crashes, like the last however many days crashes that you've registered. So all that gets phoned home to the upstream lab, and we have a database of all crashes of all the clusters that are reporting. So I think there are like 150 Ceph clusters right now that are phoning home telemetry, and there are like 16,000 crashes or something. Most of those are from like 2 clusters that are just like in a crash loop. But so we basically have a database of all these crashes, and we know what the stack trace looks like and what version basically. So it's just this part, just this metadata. It removes this so you don't have host names. It removes the host name here, so it's anonymized. Really, it's just like what version it is, what type of daemon it was, and what the stack trace was. So then on the back end, this is all in a Postgres database. There's a script that processes the telemetry reports and processes the crashes. It builds a hash, basically a fingerprint of the stack trace, where it strips off the numeric offsets. So it's just the symbolic names basically, and puts them all together and does a hash. And so there's a fingerprint of all this. Let's see.
And that hash also includes the assert message if there is one.
Yeah. Let's see if I can bring up an actual one. Hold on. Let me share a window that actually has.
We're not capturing any binary data.
No. Yeah. This is intended for upstream, right? So it's purely anonymous data. It's just what version, what type of daemon, a hash or UUID, a unique random value for which daemon it was in the cluster, so we can tell if it's the same daemon crashing or different ones. But it's anonymized, and then the stack trace. And the stack trace is just like the code, the symbols in the code. There's no actual data in any of it.
Yeah.
Because the idea is to get as many users as possible to turn this on so that we can tell what crashes people are seeing in the wild and then prioritize what we're fixing.
And you think that sending random snapshots of their address spaces might not be
yeah, definitely not
viable for a lot of them. Okay. No worries.
Yeah. Okay, so this is what there's an email that goes out daily, basically, that summarizes this. So there's the signature, the crash signature. It tells you how many clusters are seeing it, what version they're running. It shows you the stack trace in the general instance, and it's sorted by like how many crashes are happening. In this case, it's linked to a tracker ticket that's in progress, and it knows that because of this ID. There's a new field in the tracker called crash signature, and if you just basically paste this into the ticket, and the next time this reporting script runs, it'll notice the ticket and it'll link it in here. So I can tell that this is one that we're currently tracking. It's still open. We haven't solved it yet, so on. It'll show the assert message if there is one, so on. So it's pretty primitive, but it actually, you have most of the information that you need here to actually derive some real value. So like one of my to-dos for this week basically is to go through this whole report in more detail and make sure that all of the crashes that we're seeing here, in more than one cluster are linked to tickets in the tracker, and that we have a fix queued up for the next Nautilus point release, so that hopefully when people upgrade, we'll see this incidents go down and hopefully not see new crashes come up. But there's the whole level of insight into like what's working and what's not working that we didn't have. We just relied on like people complaining on Ceph users and like us noticing. So it's progress. So this is all upstream. Again, it's all carefully done so that it's there's no identifying information, so that like these cluster IDs are not the cluster FS ID. It's a different unique ID, so we don't know who these clusters are. We have no way to contact these people, for example, if we want to talk to them. We just don't know. All we know is like how big their cluster is and what version it's running. For like downstream products, it's like a totally different set of requirements, right? Like we want to have all kinds of identifying information. We want to know everything about their cluster so we can like preemptively go help them. And so with the Insights integration, for example, the Insights report is basically like a huge JSON dump of like a million things about the cluster, including all the crash dumps, and that gets phone hooked through the Red Hat way to the Red Hat servers or whatever. And in that case, the crash dumps are also there. Dan just did a pull request so that this crash signature is generated on the cluster side instead of on the backend side, and so we'll have the same signature when we look at the crash dumps in Insights. So we can we can check whether it's linked to an upstream tracker. We can have it in like the downstream Bugzillas. SUSE can go do the same thing on their backend, whatever it is. But you have this like two different channels, right? The upstream telemetry is all anonymized information, and we want to be able to have our customers be able to turn that on also if they want to or not. And then we have a totally separate pipe of information for the downstream identifying trusted party that is basically giving you white glove service on your cluster.
So far, we've just got just under 400 clusters reporting regularly, by the way.
Oh, nice. Okay. That's good. I think it's less. I think it's less than that. If you select the ones that are reported in the last couple of weeks, then it's like 170.
Yeah, it could be.
Yeah, because some people turn off or the cluster goes away or whatever. But yeah. Yep.
This service turns on basically whenever you're like a global daemon process, like RBDMir automatically would get it working too, and
yeah. So you should just make sure that RBDMir has if RBDMir has it's in like global init or whatever, if it calls into there and installs the default signal handlers.
Okay.
So that, for example, you get crash dumps in the log. If that's enabled, then this will work. It'll generate a dump in varlib crash. The only trick is that you have to have the crash daemon running on that host. Let's see, I can't remember what actually. I think it's when you install the Ceph package. I can't remember what deploys that daemon. Actually, now that I think about it, I forget.
How does it work in containers?
So the container stuff is new. I just did it. So there are two sides. There's on the Rook side, Sebastian is working on this right now. He's working on the pull request to make Rook basically schedule a pod on every host that's running the crash monitor thing or whatever. I can't remember. I don't know how he's doing it, whether it runs it periodically to scrape them up or whether it's there all the time, whatever. But he's basically doing this for Rook so that Rook will scrape these crash metrics and push them up to the manager. For the new SSH orchestrator stuff, every time you deploy any daemon on a particular host, at the same time, it also ensures that there's a pod, a container on that host that's running the crash monitor.
And it just like bind mounts that directory into the.
Exactly. Yeah.
Okay.
Right. Yep. Yeah. So all pods, all containers for the same cluster FSID are bind mounting the same varlog directory and the same varlib crash directory and the same var run Ceph directory. So they're all sort of like glued together in that sense. And if you open a shell container, you specify the cluster ID, you also get all that stuff. So you can do Ceph admin, Ceph daemon commands, and so on. So on the SSH orchestrator side, it's all wired up. I think right now the Ansible deploys these, but I don't remember exactly how it does it. I just know that it does. Ceph deploy does not. So like on those people won't get this, I think. I can't remember exactly how it works, to be honest. It might be that when you install the package, by default there's a systemd unit that's just part of the package, and you just have to have a key installed on the host, and then it just works. That might be it. I can't quite remember. I don't know. That'll become less relevant over time.
What about client systems?
Say it again. Oh, clients.
What about clients?
Yeah, they don't get to play. They don't get to participate because when you load a shared object, we don't install a signal handler for Sigabort. So like QEMU, when you use Liberatus, we don't futz with the signal handlers. We let QEMU do whatever it wants to do. Yeah.
Yeah. I'm sure the QEMU people will let us know anyway.
Yeah. If we mess with their signal handlers, you mean?
No, if somebody notices a crash, they're going to report it to them rather than us.
Yeah. Yep. Yeah, I think I'm slowly remembering here. I think the one thing that I just realized recently, so this was added in Nautilus. It was supposed to just work out of the box. I wish I could remember. I'm pretty sure it's because the package just includes the systemd unit that is supposed to be running on its own. But in Nautilus currently, it relies on there happening to be a client.admin key already installed on that host. So if client.admin is in etc Ceph, then the crash monitor will work. But if it's not, then it won't do anything because it won't be able to talk to the manager to push it back up to the cluster. Starting in the backport, that's going to go into 14.2.5, this next Nautilus point release. The crash agent will try, it'll first do client.crash.hostname. If that key doesn't exist, then it'll try client.crash, and if that doesn't exist, then it'll try client.admin. And so with that update and changes to Ceph Ansible or whatever to actually create a per host key on every host and install it, then we'll be able to, it'll actually start working. But right now, basically, we're only scraping crashes on hosts that happen to have the admin key installed, which is usually like monitors or something like that. So like if you look at this at that cluster I was just looking at, if I do Ceph crash ls, it's kind of embarrassing, I never noticed this, but like all of the crashes on here are all monitors and they're OSDs that happen to be on hosts that have monitors on them. And so we're not actually scraping the crashes on all the other OSD machines because the keys aren't installed. So that needs to get fixed here soon. But that all goes away with Octopus and the SSH orchestrator. When we deploy the daemons, then we generate a key as we deploy the daemon and the crash agent. So it all just works. And Rook is going to do the right thing also. So moving forward, it'll be a little bit cleaner.
Would it be a good idea to implement an option where you can enter a stack manually into the database? I mean, obviously, there'd have to be some level of trust, but the other thing is the inverse of that is being able to search the database by entering a stack.
Yeah, so as far as reporting to the database, you just need to install the crash reporting or cluster and then tell it to phone it home. That's probably the easiest way. It's just a REST endpoint and you post to it. It's like wide open to the world, like anybody can put whatever data they want in there. We're just sort of hoping that nobody puts garbage in.
The thing is, I'm thinking something like the client, such as the QEMU example.
Yeah.
Where
so if it just generates
could potentially.
If they just generate the JSON that is of the same form, then you could post it. Or you could just dump it into the. As far as searching it, right now it's in Postgres. So if you have access to that Postgres database, you can do whatever select queries you want. There's like a huge list of like things that we could do as far as like having a little GUI that lets you browse them and let you you look at a crash by signature and you have a histogram of what versions. You click on version, you have a list of the top crashes. You click on a cluster, you see all that cluster. I mean, you could go around in circles, like making that like a nice browsable way to like look through this database, but none of that exists yet. So right now you're just writing select statements to look through it.
Yep.
Be a great intern project, perhaps. We get like somebody just spend a summer who likes writing web GUIs to do something like that.
I hope to get to something slightly less primitive sometime soon, but we're still sort of hammering out what should be in the reports.
Yeah. Yep.
Yeah, we're better off getting the structure right before we start going for bells and whistles.
Yeah, exactly. Yep. Cool. All right.
Okay. Thanks for that.
Yeah, no problem. Anybody else have any questions, topics? All right. Going once, going twice. Have a good week, everyone. Take care.
Thanks.
Have a good one.
Thanks.
Thanks, everyone. Bye-bye.
Bye-bye.